Okay, when we're trying to assess the difference of numeric variables, we have to be really careful about understanding how the data is structured before we choose a method to actually use. So in this case, we have to start by reading very carefully to see if the samples are dependent or independent of each other. Um, in this particular situation, you've got somebody trying to see if somebody's going to do better on Minitab or on Excel. So one idea would be to give each student a quiz on Minitab and then give them each a quiz on Excel. The questions aren't the same just because you don't want necessarily people to just be remembering the answers, but you want to see if using the softwares makes any sort of difference. But the order, when they use Minitab first or when they use Excel first, is completely random. And 20 students are selected. So here you can see that you've got, here's student 1, here's their score on Minitab, and here's their score on Excel. Okay, so each student took a test, and that's what makes it so the pairing seems logical. So here, instead of comparing this student's Minitab test to this student's Excel test, which makes no sense, compare this student's Minitab to this student's Excel. There's a lot of strengths or weaknesses that can be canceled out. The other thing to notice is that the sample size is for sure the same. Okay, so just because the sample size is the same doesn't guarantee that things are paired, but if the sample sizes are different, then there's no way it can be paired. So I think in this situation, it's fine here to assume that a pairing makes sense. Once we've decided that it's a paired situation, then really we need to assess the normality of the difference between these variables. So here in column 5, I'm just going to put difference and go up to calculator. And in column 5 there, I'm going to take whatever's in column 3 and subtract whatever's in column 4. And so what I'm going to get here is this number subtract this number is right here. So when I have a paired situation, I want to assess the normality of the paired differences. Okay, so when I do a normality test, I want to make sure that I do a normality test on these differences. Okay, so here, when I go through and I find out if the differences are normal, here you can see the p-value is very high for the normality test. Therefore, it does appear that the differences are in fact normal. So here I just said the differences for Excel versus Minitab are normally distributed. Notice that some of these other statements might be true, but they're irrelevant. To run the test that we want, which in this case would be then the paired t-test, because the differences are normal and they have logical pairings, any other information which might be true is completely irrelevant to which test I'm running. At this point, of course, we want to assess if students that took the Minitab test or students that used Minitab, if their score was higher. So if you had Minitab and you subtracted Excel and you were expecting that Minitab was better, if you've got big minus small, you would be saying this number is greater than 0. So there's a lot of notation here. We want to be using a mu and not a mu with a tilde. So the mu means mean, and we can use a mean seeing as we've got normal distribution. If we didn't have the normal distribution, if we didn't have normality coming out, then we'd have to use the Wilcoxon signed rank test, and that would look like one of these hypotheses with the tilde on top. So here, the difference between Minitab and Excel, I know that I'm using a paired test because I'm using one of these mu sub d's. And in this case, I know that it's the paired test because there's no tilde on top. And here, if I'm trying to see if Minitab did a better job than Excel, then big minus small should be positive. Okay, so once I've got all that worked out, I can actually run the test by going stat, basic statistics, a paired t-test. The data are in columns here. Sample 1, which is Minitab, subtract Excel. Okay, so Minitab and Excel is the second one. And of course, I need to make sure that I have the sign in the alternative hypothesis to be the sign that I want it to be, the greater than sign. And you can find here then the test statistic and its p-value. Okay, something else of note, even though the Minitab doesn't state it here, the degree of freedom for a test of the degree of freedom for a paired t-test is the number of pairs. So here in this case, 20 minus 1. So the degree of freedom would be 19, even if it's not mentioned here. That is in fact what the degree of freedom is. So I put in the test statistic. Here, to interpret a p-value, we always know that we start with, given that the null hypothesis is true, then the probability of observing stronger evidence against the null hypothesis is, of course, this p-value here. In this case, that p-value is quite small. We know that we're going to reject the null hypothesis. When we're trying to interpret this, I guess we could say, based on these samples at the 5% level of significance, so comparing this number to 5%, we know we're going to reject the null hypothesis, which means that the mean of Minitab is significantly higher than the mean of Excel. How do I know that these are means instead of medians? Well, I'm not running a non-parametric test. I did a paired t-test, which means that I am basing this on means, not on medians. And again, then, if in fact the data structure were the same, but our p-value for the normality test was small, then what test would we do? It would be the Wilcoxon signed rank test. And I'll just quickly show you, if that was the case, how you could do that. That would be non-parametrics and a one-sample Wilcoxon. Here, you need to make sure that you use this column of differences. So I can put in column 5, the column of differences, and I can test the median that the difference is in fact greater. So here, this will run the Wilcoxon signed rank test, and you can see even if I use the Wilcoxon signed rank test, I would also reject the null hypothesis, as I did when I used the paired t-test.